All right, today we're going to be learning about the normal curve and z-scores. This right here is the picture of the normal curve. In the middle, you're going to have the mean, which we represent with the Greek letter mu. It looks like that. Kind of looks like an M and a U had a baby. All right, so we're going to come back to this picture in a little bit. Standard deviation is a standardized unit of measure things that we use for measurement is like feet or inches or miles or kilometers. Standard deviation is just another way we could measure this distance. So each one of these little tick marks on our normal curve, the mean's in the middle, and then each tick mark away is one standard deviation. So this side is +1. The symbol that we use for standard deviation is a lowercase sigma. It's like an O with a tail. Kind of looks like Tails from Sonic the Hedgehog when he spins up and rolls. So this is +1 standard deviations. This is +2 standard deviations. This is +3 standard deviations. On the other side, we have -1 standard deviation away, -2 standard deviations away, and -3 standard deviations away. And those marks are the same for everything that's measured under the normal curve. Now, how much each standard deviation is worth changes based on your data. Now, we can calculate standard deviation given a set of data. You can do it by hand. There is a formula for it, but it's a lot easier to do it on your calculator. So, to put this data in, we're going to go to Stat, and then choose Enter for Edit. If you need to, go up and clear out your list, so clear and enter. And then we're going to put in our set of data. So 4, 9, 11, 12, 17, 5, 8, 12, and 14. And you don't have to worry about what order the data is in. Then you're going to choose Stat, scroll over to Calc, and you're going to choose number 1, push Enter all the way through Calculate, and we get X bar at the top. That's our mean. So that's going to be our mean. And then our standard deviation, we got the standard deviation symbol, is 3.938. All right, so next we're going to talk about z-scores. A z-score is the number of standard deviations away from the mean. So if a data point is 2.5 standard deviations above the mean, it has a z-score of +2.5. If a data point is 1.5 standard deviations below the mean, its z-score would be -1.5. So positive z-scores means it's above the mean, negative z-scores mean it's below the mean. So what value would that mean for the data above? We're going to start with the mean, which was 10.222. Since it's above, we're going to add 2.5 times the amount of the standard deviation, which is 3.938. Yeah. Type that in your calculator. 10.222 plus 2.5 times 3.938. So for this set of data, it would be 20.067. All right, what if we wanted to know what data point would be 1.5 standard deviations below the mean? Still going to start with the mean. Since it's below, we're going to subtract 1.5 times the standard deviation. And if you want a shortcut for typing it in your calculator, scroll up and copy and paste this down. And the only thing we have to change is change it to minus 1.5 instead of plus 2.5. So instead of plus, we want minus, and instead of 2.5, we want 1.5. Push enter, and our data point is 4.315. Now let's look at how we find a z-score. The formula for z-score is x minus mu over sigma. Mu, remember, stands for the mean. Sigma stands for the standard deviation. And x is our data point. Something is considered statistically unusual if the z-score is more than plus or minus 2 standard deviations from the mean. So if it's more than positive 2 or smaller than negative 2. So let's look at an example. Kelly's test score on the quadratics test was 95. The class average was 78 and has a standard deviation of 5. So in our formula, Kelly's score, that's our data point. That's our x. The class average, remember average means mean, and then a standard deviation of 5. Determine if Kelly's score is unusual using the z-score formula. So our z-score formula is x minus mu over sigma. So our z is going to equal 95 minus 78 over 5. When we do this in our calculator, to get that flat fraction bar, we can do alpha, y equals, and then enter. So we do 95 minus 78 over 5. Now what this does is it's going to give us our answer as a fraction, which doesn't really help us out. So what we can do is do math, change it to a decimal, enter, enter. So it's 3.4. Since 3.4 is bigger than 2, Kelly's score is unusual. She did unusually better than most of her class. Now, z-scores can also help us compare two sets of data that aren't exactly about the same, aren't exactly identical. So, in order to compare two sets of data, we must convert to the z-scores first. So, suppose your friend earns an 80% in AP World History and a 90% in Art 1. The average score in AP World History was a 72% with a standard deviation of 6.5. The average score in Art 1 was an 88% with a standard deviation of 3. Statistically, what grade is better? So we're comparing two different things here. We're comparing AP World and we're comparing Art 1. Which, as far as effort and workload and the amount of information, there's a lot of difference between them. So first, let's look at the information for AP World. She got an 80% in AP World. AP World has a mean of 72 and a standard deviation of 6.5. So we know that Z will equal 80 minus 72 over 6.5. For Art 1, your friend got a 90. The average score is 88, and that has a standard deviation of 3. So our Art 1 z-score is going to equal 90 minus 88 over 3. So let's calculate these. Alpha, y equals, enter, 80 minus 72 over 6.5. So because it was such a weird decimal, it was a nice one like this, it changed it to decimals for us anyways. So we're going to round to 3 decimal places, 1.231. Our z-score for Art 1, alpha, y equals, enter, 90 minus 88 over, forgot to arrow down, over 3 gives us 2/3, or as a fraction, as a decimal, it's 0.6 repeating, so equals 0.667. So which score is better? AP World is better because it's farther above the mean. Now in our last problem, we're going to look at working backwards. We have a normal distribution with a mean of 235.7, a standard deviation of 41.58, and we know the z-score this time. So we want to know what x equals, what our data point is. Now, if you look back, these problems right here were asking for the data point, right? And the numbers that we were using here were the z-scores. So what we're going to do is use the same idea. Take the mean. Since our z-score is negative, we're going to do minus 3.45 and multiply it with the standard deviation. we get that our data point is 92.249. The other way you could do this is use the Z-score formula. We know our Z. We're trying to find X. We subtract the mean and divide by the standard deviation. To solve this, we would multiply both sides by the standard deviation. And look, this right here, same as that part right there. So on this side, we get negative 143.451 equals x minus 235.7. And then to get x by itself, add 235.7. And we still get that x is 92.249. And that's all for z-scores.